So how does that reabsorption happen? We've said that the water, right, this would be too much water to lose. We've got to get most of that water back. How does that reabsorption take place? Okay, this is going to bring us moving into the next section of the nephron. So first layer of filtration has taken place at the glomerulus, and now the water has moved on into the proximal convoluted tubule. This is one of the main sites where reabsorption of water takes place. The way that this happens is quite interesting, and it's going to bring us back to thinking about diffusion and osmosis. As a result of this reabsorption, most of the water is going to travel back out, so it's going to diffuse out of this tubule, and it's going to be absorbed by those peritubular capillaries. It's going to rejoin the blood there. Pretty amazing. The amount that gets reabsorbed, this is tied to how much water we consume. If we're dehydrated, then more of the water is going to be reabsorbed. If we're well hydrated, or if we've been drinking a little bit more water than we need, then more of the water is just going to stay in the tubule. So there are amazing control mechanisms in place here. Ordinarily, about 85% of the reabsorption of water happens right here in the proximal tubule. There's going to be a little bit more water absorption later on, we'll get to that, but most of the water reabsorption takes place right here early on in the nephron. If a person is dehydrated, they will still urinate a certain volume every day. 400 milliliters is the minimum amount that has to be excreted just in order to flush out the wastes that the kidney filters out. So there's a certain obligatory amount of water that we will lose just in the process of filtering the blood. So this is why a person cannot survive for very many days. A person cannot survive more than, I think it's about 3 days without consuming water. And that's because we would be losing volume through the urine, and then our blood volume would start to drop as a result of that. The osmolality of the filtrate, so the stuff that passes through the glomerulus, that filtrate has an osmolality that's the same as blood plasma. Okay, so that means that there's really no driving force for water to leave, right? If it's an isoosmotic fluid inside and outside, why would water move? So in order to get water to move out of that proximal tubule, what happens is sodium is actively transported out. So we've got sodium transporters. We can use some energy, transport sodium out, and then the water is going to follow it. Okay, so let's see how that happens. Reabsorption of water. All right, so inside of the proximal tubule, which is, again, that's this section here, the proximal tubule, if we were to take a look at a close-up of the inside of this tubule, we would see microvilli. Okay, so that's going to provide a very large surface area over which absorption can happen. The outside of the proximal tubule, the outside has pumps for sodium and potassium, and they are pretty much always active. That basal membrane, it's always going to be pumping those ions. So inside the tubule, the sodium concentration is higher than inside of the cells. And just think about that for a second. So, right, the filtrate passes through this tubule. It's got sodium, it's got water. The cells lining the tubule, though, they're always pumping sodium out, okay, to the outside of the tubule. So that means the cells themselves are low in sodium. So there's going to be a driving force for sodium to move from the filtrate into those cells lining the tubule. Okay, so that's the first step, getting that sodium to move. Once it's inside of the cells, it will actively be pumped out of the cells, okay, to this external environment. It turns out once that happens, once sodium is transported out, chloride tends to follow it. They are oppositely charged, so chloride will follow along with it by passive transport, no energy required for that to happen. And then what we've just done is we've moved salt to this outside space, to the interstitial space. And so then there is a driving force for water to move. Water will leave the tubule into this interstitial space. So overall, about 65% of the salt and water is reabsorbed this way. There's more that's still going to be absorbed, but this is the bulk of the absorption. It's happening right here. And then once water is in this interstitial space, it will just diffuse into these capillaries and rejoin up with the blood cells.